Hello, my name is Arion, and this project combines computer vision with embedded hardware to create an interactive real-time system. On the software side, I use OpenCV to capture live video from a camera. Each frame is then converted from BGR to the HSV color space, which makes color detection more stable under different lighting conditions. The program looks at a small region in the center of the image and then averages the pixels in that area to reduce the noise. And based on the hue, saturation, and brightness, it classifies the detected color. The detected color name, along with its RGB, and HSV values, is then sent over serial to an Arduino in real time. On the hardware side, the Arduino controls an RGB LED and a 16x2 LCD. In the default mode, the LED displays a preset version of the detected color so it appears consistent and visually accurate. At first, I was going to try and display directly the RGB values that I sent over serial, but it didn't look correct on the RGB LED due to like the different brightness and things that happen on the computer screen versus a singular LED. And then one button is used to cycle through the LCD pages, which show the detected color and RGB values, the HSV values on the next page, and a scrolling color history that visualizes recent detections over time on the third page. A second button controls the LED mode. Using this button, I can switch the LED from the vision-based color output into a smooth rainbow animation or into a gator mode that cycles through blue, orange, and green on a periodic time interval. Overall, this project demonstrates how computer vision data can drive real-time hardware behavior, with user controls layered on top for interaction and visualization. I'm just going to scroll through my code quickly. Here's the Python code I use for the OpenCV stuff. And then from that, the Arduino code in C. Yeah. Okay, and I already uploaded it onto the board. I'm just going to show you my wiring real quick. Very simple stuff, and the LCD screen. Right now it's in the default mode, or not default, but like before anything happens, so it just said color detector. Now I'm going to open the color recognition. I'm going to start where we left off and open the color recognition RGB Python file. And the screen should pop up perfect, and then this default screen now changed to one of the pages. Okay, this circle in the center, the black little circle, is where we are deriving the 5x5 grid of pixels that we're using to average the color values of. And then in the top left of the screen, it displays the word for the color that it is determining from the pixel values. And then it also uses those exact HSV values to display the color of the font. So we're going to hold the red folder up in front, and you can see it change immediately along with the red LED. I'll move it away. It picks up my skin as different colors. That's why you're getting the variation. Okay, move the folder in front. Okay, and here you can see the color is red. We're in the vision mode and the RGB values. All right, perfect. I'm going to try and hold the folder in front while I press this button to change the page that we're on. Now we're on the HSV mode, still color red vision mode, and then the HSV values, and then we're going to go to the color history, where it's all filled up with red right now. Let me move the folder, get some different values. Here we go, you see it's loading with white. I'm going to go back to red. Perfect. Okay. Now I'm going to show the right button is to change the page that we're on for the LCD. Now I'm going to change the mode of the LED. Right now we're using the colors from the OpenCV that we're transmitting over serial. I'm going to change it to the rainbow animation. So it'll run through that. And you see this screen also lines up. You can see the values incrementing and decrementing for the RGB. I'm just going to let it play through one full cycle. And I have it so that the HSV values are constantly from the screen, so it doesn't matter what mode we're in for the LED. However, for the history, it is dependent on just the LED value. So right now we're entering blue territory. We were from cyan, and then it'll most likely go to purple or pink. Yep, purple, and then followed by pink, I presume. Pink we have designated as a K, so nope, it looks like it didn't track that and went right from red. Okay. Now I'm just going to show that this works with some other colors and stuff. So let me change the mode of the LED. Oh, we also have the gator mode. It'll go through red, green, and orange. So you see it filling up with that pattern there. Gator mode, history. I'm going to change it to the RGB page. Okay. See it cycling through blue, green, and orange. And then the values changing. Okay. While this is going on, it still has the same function up here. So we'll show that while that's happening. Okay. Let's grab a blue folder now. And I'm going to change this back to the mode for tracking. Okay. We have the blue folder. Blue, blue. Boom. Blue, sorry, got my finger in there. Blue. Okay. Now this will track as a pink, I believe. Yep, pink, and then pink. Okay. And then we have the little gator here. We can get some different values. You can see in the top left. Okay, and then we're gonna look at here. Right now I have the green showing. I'm gonna go to the orange, or try to. There we go. Yeah, orange. Then it'll do white, and then let me try and find some blue in there. Okay, got some blue. Perfect. And then I also have the Fundamentals of Logic Design textbook. We get yellow and white from here. So, yeah. There is the functionality of that project. Thank you. To build on that idea, this second project focuses purely on computer vision and color-based object detection using OpenCV. For this project, I defined preset colors in BGR format. This makes it easy to switch which color I want to track without changing the detection logic itself. Each camera frame is again converted from BGR to HSV color space, and using the selected color preset, I generate a binary mask that highlights only pixels within the specific hue range. This function also correctly handles hue wraparound, which is especially important for colors like red and HSV. From that mask, I compute a bounding box around the detected region and draw it directly onto the live video feed. If the target color isn't present in the frame, no bounding box is drawn. By simply changing the color preset, I can track different colors without modifying the rest of the pipeline. This demonstrates how color segmentation, masking, and object localization work together in a clean modular computer vision system. Here's the code for my color object tracking Python file, and then the supported function as well. All right, I'm gonna run that in the terminal. And right now we are tracking blue objects, as you can see here. So I'm gonna grab my blue folder, and as you can see, we're just gonna track that around the frame. Sometimes it'll pick up other instances of blue in the in the frame, and then that'll expand the bounding box. Okay. Now I'm gonna switch that to yellow to show that it works with other. Control S to save. Okay. Run it again. Let's make sure it did save. Okay. Perfect. I'm gonna grab my digital design book, and then we can see that get tracked. And this also works for smaller objects. I have a little yellow fan that I'm going to track. Almost appears that it works better with the smaller object. But yeah. That's my demonstration. Thank you for watching.